Hey guys, welcome to another lesson. So today we're going to do another one of these nice questions in the series of videos that I'll put out where I'll just do a quick question, ones that I like or ones that I think are going to be quite common in exams just to make sure, you guys know how to do it. So today's lesson is in the Extension 1 syllabus from the topic of differential equations. So a very classic question that touches on logistical growth, so applications of differential equations, logistical growth, very common. Here we go. Let's just do it. So this is from St. George Girls 2021. So very quickly, just walking through this. So an area of a centimeter squared is occupied by a bacterial colony. The colony has its growth modeled by the logistical equation, blah. At time zero, the area occupied by the bacterial colony is ½ centimeter squared. So it's logistical growth because it has this format, doesn't it? It's got a constant in front and it's got a 50 minus a as its differential equation. So you commonly see that as like k, p, n minus p, right? Same thing. So the first part is important because show that this guy here, because in 3-unit maths, unlike 4-unit extension 2 maths, you can actually integrate this, right? In 4-unit maths with partial fractions, but in 3-unit, you don't know the techniques or how to, right? So they need to give you this part A or part 1, where they basically re-express the differential equation into the sum of two fractions, which is then integratable because we can use ln, right? And then we derive the logistical equation itself, the solution, right? You can see there, they've got all the constants sort of figured out because they've given us information to do so. And then lastly, using this logistical equation, we're going to answer a question about limiting value or limiting area. So very classical. Let's get started, right? So for part 1, right, it's a proving question where I'm going to be big brain and go from the right-hand side proving to the left, right? So in this case, 50, let's say 1 on A plus 1 on 50 minus A, yeah? Always start with the two fractions proving to 1. It's easier, right? So then all I got to do now is common denominator the bracket fractions, right? Where it becomes like A times 50 minus A. Yeah, and you sort of like cross multiply, don't you guys? Cross multiply that, and you get 50 minus A plus A, right? These guys cancel out. Yeah, so I'll do it, one more step than I normally would, where I go and show the 50 still there, and then I'll cancel out with the 1 on 50 outside. Yeah, that guy goes away, and so then you're left with the left-hand side. Nothing too wow about that, right? Very straightforward algebra. That's the left-hand side, done. Now, why did I need that? Because when I do differential equations and I swap the sides, etc., I need to be able to integrate this expression, which now can be done using this proof, right? So I'll show you what I mean. So can I just, I'm just going to move on to the next slide. Is that right? Because the next question takes a little. I'll make another spare slide just in case. All right, just to zoom in a bit. All right, guys. So we are now going to, for part 2, start with the differential equation of dA dt equals to 1 on 25. Yeah, 1 on 25, A times 50 minus A. Now, like I said in previous videos for differential equation, I need to put all my A's in the same side, on the same side, and put my T's and constants probably on its own side. So I'm going to move this dt up here, and I'm going to move this blue highlighted part down here, right? So I get 1 on A times 50 minus A dA equals to 1 on 25 dt. And then I'm going to integrate both sides, right? Yeah. Now, like I said, guys, integrating this bit here in 3-unit extension 1 maths really is unfair because you don't know that 4-unit students, extension 2, partial fractions, quite easy. that's why they make us do part 1. So I can use that, I can pop that expression into here, right? So I can then integrate it. So it becomes like integral. Now, I'll bring the 150 outside when I do this. Integrate 1 on a plus 1 on 50 minus a dA. And on the other side, I can start integrating that to be t on 25 plus c. Just a, I guess, gentle note that when you're integrating both sides, you don't need 2 plus c's, you only need 1, which is like the collection of all unknown constants, right? Yeah, guys, to integrate this guy here, that's ln, right? But this guy here, I need the derivative up top, so I need that to be a minus, which means I need this guy to be a minus, right? Just be careful with that. So 1 on 50, and it'll be log of a, yeah, minus ln of 50 minus a equals to t on 25 plus c. Yeah, nothing too hard about that now. So I'm going to do 2 things now. I'm going to combine the logs using my log laws, minus divide, but also this guy and this guy, that's times everything by 50. So the 2 logs combine to give you a 50 minus a. And when I times this side by 50, that becomes 2t. Now, guys, c times 50, c is unknown, multiply by 50, it's unknown. I'll just let it be c as well, right? Don't need to change that. All right, now, what am I trying to do? If you look at the question, I'm trying to make a the subject, right? So I need to get rid of the ln and then algebra my way through this, right? So a on 50 minus a equals to exponential 2t plus c. Now, I always ask my students, is it okay if I re-express this guy as e2t times ec? So basically break the fraction, break the powers, and then replace ec, c is a constant, e to the power of c is a constant. I'm just going to replace this with the letter capital A. That's the letter that most teachers will want you to use, e2t, right? So basically you go, oh, sorry, A is not the letter because I got a different A here. So maybe I'll call that B, right? So all other instances you use A, but this one actually has another variable of A, so let's not use that. So this becomes A on 50 minus A equals to B E 2T, right? We can find B closer to the end when I sub in my initial conditions. How much space do I have? Not a lot. What does 1 do? You know what? I get rid of this arrow. I move this whole thing up. Perfect. All right, I'll zoom in again. Guys, a bit of algebra. Times the 50 minus A up, right? So it becomes like A equals to B E2T, 50 minus A. And I'm just going to rainbow this, expand that. Yeah, and then get A equals to 50B E2T minus AB E2T minus the, plus the AB over to this side equals to 50B E2T, and then factorize A on this side, 1 plus B E2T equals to 50B E2T. Oh, damn, I'm very close. So what I can do, and this might be sneaky, I'm just going to do that, and then I'll just pop upstairs if that's okay. So come upstairs with me. All right, come upstairs here with me. All right, because what I'm going to do, guys, is I'm always there. I need to make A the subject, right? I need this guy the subject. So I'm just going to divide this bracket over to the other side, and I'll get, well, you should get, therefore, A equals to, is it 50B E2T over 1 plus, short memory. 1 plus BE to T. Okay, cool. BE to T. All right. Now, just a quick glance at what I need to prove. Got the 50. Okay, cool. Perfect. Now, this is what I always say to my students at this point, right? Look at the thing you need to prove. What do you note? A couple of differences. Almost there, right? Almost there. But the biggest thing to note is that the thing you have to prove on top of the power of E, in the power of E, it's a negative 2t. Right now, on my E, it's a positive 2t. And also there's an E, 2t upstairs. So what do, guys? I'm going to divide top and bottom by divide by BE2t. Divide top and bottom by BE2t every term, right? Every term. Because then on top, the BE2t goes away, right? That guy goes away and you get 50. Great. Exactly what I need in my proof, right? Now, 1 divided by this guy is 1 on BE2t. Sweet. And then plus BE2t divided by itself is 1. Yep, perfect. Almost there, right? Now, can you see it's because of this guy now? E's on the bottom. That's why it becomes negative, right? So I'm just going to rearrange this to make it, therefore, A equals to 50. I'll put the 1 first, and it'll be 1 on B, E minus 2t. Great. And at this point, I will need to sub in something to find my B. Now, what's that something? Initial conditions over here, right? At time 0, when t equals 0, the area is half, right? So when t equals 0, A equals to half. Let's sub that stuff in. So half equals to 50 over 1 plus 1 on B. Guys, E to the power of 0. That goes away. So I switch it around. 1 plus 1 on B. Well, gone. Equals to 50 on a half. And what's that? 99. Is it 1 on B is 99, right? So pop this guy. So I don't need to make B the subject, right? Because it's 1 on B. I don't need to make B and then reciprocate it, right? Because right now, 1 on B is 99. Let's pop that into here. You can see that's exactly where this question wants to be. So therefore, the logistical question, right, or equation is 51 plus 99E minus 2t. So a lot of students get caught up and leave their answer with a positive 2t on top of the E. The question has negative. You just need to divide everything by E2t with a B in front. How's that, guys? That's the hardest part of the question, because thereafter, the final part of this question, right, is that according to this model, what is the limiting area? Limiting area, the word limiting always implies when A goes to infinity. So that's a lie. What is the A when T goes to infinity? Yeah, when time goes to infinity, limiting, right? And he wants you to find what A is, right? A equals to question mark. So for part 3, maybe I'll do it here, right? When T goes to infinity, A is what? Now I know that, right? When T goes to infinity, E to the power of minus 2t, right, goes to what, guys? When T gets very large, any negative power, right, any term with a negative power goes to 0. So in your A expression, right, A equals to 50, 1 plus 99E minus 2t. This bit here goes to 0. That's gone. So the answer is 50, right? It goes towards 50 centimeters squared. How's that? Guys, I thought I'd give you this punchy question on logistical growth, right? It's going to be common. A lot of schools will have it. They basically have the same structure, different context, different numbers, same approach. Hopefully that was good. Guys, if you like that, like the video, subscribe to the channel and tell your friends. Thank you.